Connect has replaced copper. Copper has issues. We have huge issues here with the hard water in Nevada. It corrodes through the pipes within a few years. So plastic is faster to install. Nobody's soldering pipes together on the house. So again, we've speeded that process up. Also included in the kit is a foam injector. So now we're spraying a urethane foam that's fire rated. So now we're locking the plumbing in place. So hot water stays hotter, cold stays colder. No freeze thaw issues if you're in a freeze environment. Next slide, please. The last thing to go on are two very high performance coatings. This is the most important part of our technology. This has evolved now into a third product called Ballisticrete, which is the world's first and only fire rated and bullet resistant, abuse resistant finish. At various thicknesses, which we'll get into, we take it now all the way up to blast level. So this is the only time we really need a skilled craftsman on a job site, and we've selected basically plastering trades have sort of gone by the wayside, certainly on the West Coast. So we do trainings here. We don't charge for it. Every Friday morning we do free trainings, and we've taken basically the stucco industry and turn them into the exterior and the interior finishers. So they're our finishing crews, and there's plenty of those guys around. On the slide, you'll see there's a vehicle. This is actually a Dodge pickup truck that's 1,240 pounds of weight, pressing down on 3/16 coating over styrofoam. So you would think the foam would crush. It doesn't. The coating is so strong. The interior coating, we're around 9,000 PSI. Concrete, good concrete's about 3,000 PSI. Excellent concrete's 4,000 PSI, with more than doubled that. And the technology basically is, it's a crystalline process. So the water that goes in, it doesn't come out. When you make concrete, the binder is Portland cement, the aggregate is sand and gravel, and you add a fourth element, and that's water, and it's typically 18 to 20% by volume. As you add the water in, you mix the concrete, it activates the process, the water comes out. What I just said was, I've just taken out 18 to 20% by volume of the concrete. That's why it shrinks, that's why it cracks, that's why stucco cracks. So our water goes in, stays in, converts and grows into crystals. Those crystals now interlock with each other. They grow into the EPS, the styrofoam, and you end up with something extremely dense. As a crystal grows, it's going to take the least line of resistance, so it's going to fill all those little nano air pockets that are in there first. As it hits a grain of sand, it doesn't quit growing, it stops and breaks and goes around it. So now you've encapsulated it. You made it super tough. So the very early experiment, I was really taking waste stream material, ash from coal-fired power generation. I knew I could use sand, but I wasn't thinking about it back in those days. I was taking sludge from paper mill, agricultural waste, rice husks, you name it, I tried it. There's a piece here on the table that's actually 50% Starbucks coffee grounds to make Starbucks coffee tables, of course.